In this video, we will use the area of a rectangle to help us think about expanding products and factoring some polynomial expressions. So if we have a rectangle, looks something like this, and it has a width of w and a length of L, then the area of this rectangle is L times w, or w times L. So anytime we have a rectangle, we find the area by multiplying the two side lengths together. Now this seems pretty simple, but we can use this idea to help us think about some other sophisticated mathematical ideas. So let's consider the product. Let's look at the product x plus 2 times x plus 3. And suppose we want to write this product out in expanded form and write it as a standard form polynomial. What we can do is draw a rectangle like this. It's not going to be to scale, but we'll say that the width is x plus 2 and the length is x plus 3. Now we'll split up this width. Since it has a width of x plus 2, we'll split it into two pieces. And we'll say that this piece has a width of x and this one has a width of 2. We'll do a similar thing for the length of the larger rectangle. We'll split it into two pieces. We'll say one of the pieces has a length of x, the other has a length of 3. If we want to find the area of the larger rectangle, we can find the area of all of the four smaller rectangles and then add those together. So let's start with this top left one. It has an area of x times x, which is equal to x squared. Now the top right has an area of 3 times x, which is just equal to 3x. And then this bottom left one has an area of x times 2, which is equal to 2x. And then the bottom right one has an area of 3 times 2, which is equal to 6. So if we want to know the area of the entire larger rectangle, which gives us the value of this product we're looking for, we just add up all the smaller constituent parts. So if we do that, we end up with x squared plus 3x plus 2x plus 6. And then we can add the 3x and 2x to write this as x squared plus 5x plus 6. So when we're looking at the product of two expressions like this, we can draw out a rectangle and split it into parts and think about the final product as the sum of the area of each constituent part of that rectangle. Let's do something a little more challenging now. Let's suppose we have the polynomial expression x squared plus 8x plus 15, and we'll assume that we want to write this thing in factored form. So we want to write this in the form x plus a times x plus b. So we don't know what the numbers a and b are, but we're going to try to find those numbers using the same approach of having a rectangle. So if we draw out a rectangle, again, not going to be to scale, and we know that one of the sides, we'll say this one has a width of x plus a, and the length of the rectangle is x plus b. We're again just going to split these both into two pieces. We'll say that one of these widths is x, and then this width is a, and then this length is x, and this length is b. Now some things we know, we can go in and fill in the areas of these constituent parts. We know that this one is x times x, which is x squared. This one is going to be b times x. This one will be a times x, and then this one will be a times b. So we have our x squared part. So if we start to match some of these things up, we have an x squared. Our bx and ax, which we'll eventually add together, those are going to add up to give us this 8x. And then our constant term down here in the bottom right should correspond to that 15. And therefore the area of this bottom right rectangle should have a value of 15. So if we start putting some of those things together, we know that a times b has to give us 15, and a times x plus b times x has to give us 8x, which tells us that a plus b has to give us 8. So to factor this thing, what we need to do is find two numbers a and b where a times b is 15 and a plus b equals 8. Think about this a while. The only pairs of numbers, of integer numbers, that multiply together to give us 15 are 1 and 15 or 3 and 5. Now 1 plus 15 is not equal to 8, but 3 plus 5 is equal to 8. And therefore, our pair of numbers should be 3 and 5. So we could say A equals 3, B equals 5, or you could swap those, it doesn't really matter. So what we end up doing is replacing these A's and B's, and we end up with x plus 3 times x plus 5. And therefore, x squared plus 8x plus 15 can be written in factored form as x plus 3 times x plus 5. And this area model is very helpful. And what it essentially does for us is tells us that a times b has to be equal to the constant term, and a plus b has to give us the coefficient in front of that x.